So we are starting the new unit, Unit 7, and it's about factoring. We don't get to do factoring just yet, but it will be soon. So we get to start a new unit. Yay, this is exciting. And the first thing we're going to talk about is we just have to get some definitions down. So polynomial terms and degrees. Let's just go through what this is meaning, fill in some blanks, but we do need to get this vocabulary down because we will be referring to it as your teachers as to what is going on, and you need to understand what we're talking about. So monomial. Okay, monomial. Mono to mono, is that? So you might have that. That will come into play in just a bit. A monomial is an expression that is a number, a variable, or a product. Product means multiply. Or a product of a number and one or more variables. So, a monomial, 3x squared, 4y, 7. These are all separate monomials. It's one term. A monomial is sometimes also referred to as a term. So, one single little term is connected by multiplication product. Okay, that's a monomial. Now, here's also a monomial, 1/3 x, or I can write that as x over 3. These are all monomials. Now, be very careful because a monomial has to be a product. Even though this looks like division, see how this is the same thing. So I can write division as multiplication. But it's very important where that variable is. So the fraction c over 3 is a monomial. However, the expression c over x, or a number over x, like 4 over x, is not, because there is a variable in the denominator. Okay, when we start putting variables in the denominator, we have to look at a couple other things. So you don't want the variable in the denominator. In the top, no problem. You can write that as multiplication. But if the variable is in the denominator, it brings up a whole other thing dealing with domain. We're not going to worry about it right now. The degree of a monomial is the sum of the exponents of its variables. Okay, so let's look back up here. The sum of the exponents. Notice we only have one. So my degree for this monomial is 2. My degree for this one, what's that exponent? 1. Now here, and we're going to talk about that in just a second. This is 1 and this is 1. So, for a non-zero constant, and remember a constant is another way of saying a number, the degree is always going to be 0. So right here, my degree is 0. Here's the reason why. Let me show you. Because if I would have a variable here, it would be x to the 0 power. Okay, so a constant actually has a variable on it, but it's x to the 0 power. So that's the reason it has a degree of 0. The variable would have to have a degree of 0 because we all know any variable to the 0 power is 1. So that's the reason. Now, 0 itself has no degree. It is 0 and 1 have all these little fluky things that you'll learn about. Okay, so let's find the degree of each monomial. What's the degree of the monomial here? Well, what's the exponent? 1. What's the degree of the monomial here? Now here I have more than one variable. If I have more than one variable, this is where that sum comes in. So I'm going to take the exponents, I'm going to add them. 2 plus 3 is 5. And what is the degree of the monomial here? Right, it's a constant, so the degree is 0. Good. Now, a polynomial. Let's look at that. A polynomial. Think about a polygon. Poly, what does poly mean? Okay, polygon is that we have a monomial. We have monomials, okay, that are connected by addition or subtraction. So some are different. And I'll show you what that means. 2 or more monomials. So as a polynomial is a monomial. That's what it's talking about. So a polynomial can just be a monomial, but usually it's 2 or more monomials. Okay, so here's an example of a polynomial. 3x to the 4th plus 5x squared minus 7x plus 1. Okay, This is a polynomial. Here's one monomial, here's a monomial, here's a monomial, here's a monomial. Okay? But because we have more than one, it's a poly. Poly, the root word there, means many. So if I have a polygon, I have many sides, because lateral, it means sides. So poly means many, many. Okay, the polynomial above is in standard form. Okay, this is going to be important. Standard form of a polynomial means that the degrees of its monomials, have we written that word enough today? Decrease from left to right. So they go from highest to lowest, from left to right, highest to lowest. See how I go 4, 2, 1, 0. So they don't have to be exactly consecutive, but I have to go highest to lowest as far as my exponents. The degree of a polynomial with just one variable, is the same as the degree of the monomial with the highest exponent, with the greatest exponent. Okay, so what this is saying, see how I only have one variable? Up here I have two variables. Okay, here I only have one variable, it's x. So the degree of a polynomial is just is the same as the degree of the monomial with the greatest exponent. So let me explain that in other words. So let's look at each of these. What's the degree of this monomial? 4. These are my degrees. This is 4, 2, 1, 0. Okay? Those are the degrees of each of the monomials. But if I want the degree of the polynomial, I'm going to take the highest, the greatest exponent. Now, if I have two variables, you have to add them together. We won't have a lot of those, not a big deal. So the degree of this polynomial is 4. Okay? That's all it means. We're going to talk more about that on the back. So let's go to the next page. Okay, we will talk more about that. Just hold on with me. After you simplify a polynomial, okay, by combining like terms, pausing for a second. So after you simplify a polynomial by combining like terms, remember like terms? So if I have 4x plus 7x, I guess, these are like terms because they have the same variable, the same exponent. So I just add the exponents. Okay. Oh, we'll talk about that in just a second. But I combine the like terms. That would be 11x. After combining them, you can name the polynomial based on its degree and the number of terms, monomials / terms. Because you can call it either one. So the number of terms, okay, it contains. So for instance, we're going to go through. This one has a degree of 1. Okay, if it has a degree of 1, it's called a linear polynomial. So linear, because it's gonna, if I would graph this, it would be a line, linear. Okay, how many terms do I have? I have 2. Okay, now think bicycle. How many wheels does a bicycle have? It has 2 wheels. So when I think of this, I take a monomial, but I'm now a binomial because I have 2. So this is a binomial. 2 wheels, okay, binomial. Look at this one. What's my degree? And this one's in standard form because notice my exponents go down in descending order, 2, 1, 0. That's my degree is 2, and this is called a quadratic. Okay? Quadratic. Power of 2 is a quadratic. And we get to do a whole unit of that coming up after this one. Now, a quadratic, that's by the degree. How many terms do I have? I have 3 terms. Okay, tricycle. That's right, it's a trinomial. Okay, here we go. What's my degree? 3. That's a cubic. How many terms? 1. That just goes back to what we already know. That's a monomial. Remember, mono to mono is what sometimes we're going to talk 1 to 1. Mono means 1. Okay, here we go. Degree is 4. Okay, when it has a degree higher than 3, we don't. Oh, no, we do. We do. Okay, sorry, I'm on the wrong thing. So degree of 4, that means that it's a quartic. Okay, a quartic. How many terms? 2. So what is that? That's a binomial. Okay, it's a quartic, but sometimes we just say it's 4th degree, but it is a quartic. Okay. What's my degree here? It's just 0. So what we call this, we name it a constant, because that's what it is. It's a constant. It doesn't change. It doesn't have any variables on it. So my degree is 0. It's called a constant. Okay. You won't see too many quartics for this here, but that's what it will be called. Okay. Now, how many terms? I have 1. Again, that's a monomial. Now look at this one. This is not in standard form. So if I were to write this in standard form, I'd start by writing 5x to the 3rd plus 3x squared minus 2x plus 1. It's in descending order, 3, 2, 1, 0. So my degree is 3. We know if it's a degree of 3, it's a cubic. Oh my gosh. Yeah, it's a quartic. But for the most part, when we're talking about, it's a quartic. No, okay, moving on. Now, this has 4 terms. It's not a 4-wheeler, okay? It's not a quad runner. It's just a polynomial. Okay, it's just a polynomial. Okay, now we're going to write each polynomial in standard form. So that means in descending order, exponents in descending order. Okay, based on its degree and the number of terms. So here we go. Standard. So here's its power of 2, so this is negative 2x plus 5. And I have to base it on its degree. It has a degree of 1. Degree of 1 means it's linear. My power, my highest exponent. How many terms? I have 2 terms, so it's a binomial. Okay. If I do this one, oh, look, I have like terms. I'm going to combine those like terms. 3 plus 5 is 8x to the 4th plus 2x squared minus 4. Okay, my highest power is 4, so this is a quartic. Now, I will also allow just 4th degree, okay, because they're not as common. And it has 3 terms, so it's a trinomial. Here, write it in standard form. Go. I want you to write these next 3 in standard form. I want you to try to figure out what they are by the degree and by the number of terms. Go. So here we go. We know that this has a power of 4, a degree of 4, so it's a quartic. There's 3 terms, so it's a trinomial. This has a power of 3, so it's a cubic. There are 3 terms, so it's a trinomial. This one had like terms, so we had to combine them.